Throughout history, every major scientific breakthrough has begun with a better way of observing the universe. The invention of the telescope revealed that Earth was not the center of creation. Powerful radio observatories uncovered invisible regions of space. Today, the James Webb Space Telescope has opened another extraordinary chapter, allowing humanity to look farther into cosmic history than ever before. Since beginning scientific operations, Webb has captured light that has traveled for more than 13 billion years. It has photographed some of the earliest known galaxies, examined the atmospheres of distant exoplanets, and revealed hidden regions where new stars are taking shape behind thick clouds of dust. Yet every stunning image released to the public represents only a tiny fraction of the information the observatory collects. Behind every photograph lies an enormous archive of scientific measurements. Infrared spectra, detector readings, photon counts, precision timing data, engineering telemetry. Together, these observations create one of the largest collections of astronomical information ever assembled. Analyzing such an enormous database is a challenge that continues to grow. Even with thousands of scientists studying Webb's observations, no human can manually examine every subtle detail hidden within billions of measurements. This is where artificial intelligence is becoming an increasingly valuable scientific tool. Modern AI systems already assist astronomers by identifying distant galaxies, removing image noise, classifying celestial objects, and detecting faint signals that might otherwise escape attention. Imagine what future generations of AI could accomplish. Not by replacing scientists, but by helping them recognize patterns far too complex for the human eye to detect. Suppose an advanced AI is given access to years of James Webb observations. At first, its results are exactly what researchers expect. It improves image processing, discovers previously overlooked galaxies, refines measurements of gravitational lensing, maps enormous cosmic structures with remarkable precision. Every discovery strengthens confidence in the system. Then something unexpected happens. The AI repeatedly highlights subtle mathematical relationships appearing across completely independent observations. These aren't identical images. They aren't duplicate measurements. They're separate regions of the universe observed months apart under different conditions. Yet the system continues identifying statistical similarities that appear far more often than random chance would predict. Naturally, scientists remain cautious. Extraordinary discoveries demand extraordinary verification. Researchers first investigate the most ordinary possibilities. Could the patterns result from detector calibration? Hidden software errors? Image processing artifacts? Instrument noise? Every explanation is carefully tested. Independent teams analyze the same observations using different methods. The strange correlations remain. No physical law appears to be violated. Nothing suggests impossible technology or supernatural forces. Instead, the data hints that the universe may contain subtle large-scale relationships not yet fully understood. Rather than claiming a revolutionary discovery, researchers begin asking a more interesting question. Have these patterns always existed, waiting for better tools to reveal them? One area attracting particular attention involves gravitational lensing. Predicted by Albert Einstein, gravitational lensing occurs when massive objects bend the path of light, allowing astronomers to observe galaxies that would otherwise remain hidden behind them. James Webb has already produced some of the clearest gravitational lens observations ever recorded. Now imagine an AI comparing thousands of those events simultaneously. Among millions of calculations, it identifies a small collection of lensing patterns that appear unusually symmetrical. Not impossible. Not miraculous. simply different enough to deserve closer investigation. Whether those patterns reflect new astrophysical processes or entirely natural statistical behavior remains unknown. But one thing is becoming increasingly clear. As telescopes become more powerful and artificial intelligence becomes more capable, humanity is beginning to explore the universe in ways that were unimaginable only a generation ago. And perhaps the greatest discoveries are still hidden inside data we've already collected, waiting for someone, or something, to recognize what we've overlooked. As researchers continue exploring the mysterious correlations, the investigation expands beyond images alone. One of the richest sources of information collected by the James Webb Space Telescope is spectroscopy, the study of light separated into its individual wavelengths. Every spectrum acts like a cosmic fingerprint. From a single beam of light, astronomers can estimate a galaxy's chemical composition, temperature, motion, and even how fast it is moving away from Earth. Across thousands of observations, Webb has already built one of the most detailed spectroscopic archives in the history of astronomy. Now imagine an advanced AI comparing billions of those measurements simultaneously. Instead of focusing on individual galaxies, it searches for statistical relationships spanning enormous regions of the observable universe. Occasionally, the system identifies recurring mathematical intervals that appear more frequently than expected. Naturally, scientists don't celebrate a revolutionary discovery. They investigate. Every possible explanation is examined first. Could the patterns result from detector sensitivity? Data processing methods? Instrument calibration? Selection bias? Previously known astrophysical effects? Only after exhausting conventional possibilities would researchers begin considering whether something genuinely new had been uncovered. Even then, caution remains essential. A surprising pattern is not proof of new physics. It is simply an invitation to ask better questions. Some theorists suggest that unusual statistical relationships could someday improve our understanding of dark matter, the invisible substance whose gravity helps shape galaxies and clusters throughout the universe. Others point toward dark energy, the mysterious phenomenon driving the accelerating expansion of space itself. Perhaps the patterns emerge naturally from interactions between these poorly understood components of the cosmos. Or perhaps they reveal nothing more than the remarkable complexity of an evolving universe. There is another possibility as well. Human beings are naturally skilled at recognizing patterns, even when none actually exist. That is why every extraordinary observation must survive repeated testing by independent research groups using different techniques and different datasets. Science advances through verification, not assumption. Yet one lesson has already become clear. Artificial intelligence is changing astronomy. Instead of replacing researchers, it allows them to explore data on a scale that would have been unimaginable only a few decades ago. Tasks that once required years of manual analysis can now be completed in days, allowing scientists to focus on interpreting results rather than simply finding them. Future observatories will only increase that challenge. Next-generation telescopes will collect vastly larger amounts of information than today's instruments, producing data volumes impossible for humans to examine alone. AI will become an increasingly important partner in discovering subtle relationships hidden within that expanding ocean of observations. Whether those relationships reveal entirely new aspects of cosmology or simply deepen existing theories, they will continue pushing science forward. The James Webb Space Telescope has already transformed our understanding of the early universe. It has revealed galaxies that formed shortly after the first stars ignited, examined distant planetary atmospheres, and uncovered structures hidden behind clouds of cosmic dust. Each discovery reminds us that every improvement in technology allows humanity to see farther, and think more deeply, than ever before. Perhaps the greatest mystery isn't whether the universe contains secrets. It undoubtedly does. The real question is how many of those secrets are already present in the light reaching our telescopes every single day, waiting for new tools and new ideas to uncover them. Every photon captured by James Webb has traveled across billions of years before reaching its mirrors. Within those ancient signals lies the history of galaxies, stars, planets, and the evolution of the cosmos itself. The universe has been writing that story since long before Earth existed. Humanity has only just begun learning how to read it. And as our instruments become more powerful and our questions become more ambitious, one truth continues to emerge. The more we discover about the universe, the more extraordinary the unknown becomes.